we are looking at the summation sign, which is sigma, and that is the symbol that we use. And we want to see how to use it, and we want to look at some examples. We are told that x is equals to 1, 3, and 5. And then somebody says sum x. It basically means you need to add 1 plus 3 plus 5, and that will give you 9. Now, sometimes we may work in a different approach of things, in the sense that if you look at this x, it has 3 values. So we can refer to this as x1, x2, and x3. So you could also find this notation being used. Because there are 3 of them, I can say is equals to n, where n is the number of values. N is equals to 3. And this is the number of values. There are 3 of them. So of xi. So it will be x1 plus x2 plus x3, which is the same as 1 plus 3 plus 5 is equals to 9. So that is the summation sign, and you can use it for various activities. For example, using the same values, somebody maybe says find summation of x squared. So it will be 1 squared plus 3 squared plus 5 squared, which will be 1 plus 9 plus 25, and that will be 35. We could also as well say, let's get the summation of x minus 1 squared. Do we square x and then we subtract 1? No. For each value of x, we reduce it by 1. So it will be 1 minus 1 squared plus 3 minus 1 squared plus 5 minus 1 squared. And this is 0 plus 2 squared is 4 plus 4 squared is 16, and the value will be 20. So you have to look keenly on what is expressed. That would be very different if we had written this summation of x squared minus 1. We are squaring x, which is 1 squared plus 3 squared plus 5 squared, and then you subtract 1. And we saw this is 35 minus 1, which is 34. You can see already the difference between part C and D. The difference is the brackets that have been used. That makes a totally different scenario for us. And it's good to keep this in mind so that you know what you are doing when we are dealing with the summation sign. I could give you other examples. For example, I tell you to find the summation of 2x. This, I can also write it as 2 summation of x. And what does that mean? It means I can put 2 outside. I just sum x. And this will give me 9 times 2, which is 18. It does not differ if I was to multiply every value. I could have also done the same. I multiply 2 with 1, and then I multiply 3 with 2, and then I multiply 2 with 5. So it will be 2 plus 6 plus 10. It will still give me the same answer. Why is the same answer? Because 2 is a constant, and therefore nothing much changes when I put it out or I multiply with it directly. So it is x, for example, minus 2 divided by 3. So what is divided by 3? So I can put 3 outside as a fraction, and then I say x minus 2. So it's 1 minus 2 plus 3 minus 2 plus 5 minus 2. And that's the equation that we have because everything is being divided by 3. Therefore, I'll put a third outside. 2 minus 1 is negative 1 plus 1 plus 3, which will be a third times 3 is equals to 1. So this should give you an idea of what we mean when we say that we are using the summation sign. So whenever you see this symbol, you look for the values that have been given, the values of x, the numbers that you've been given, and then basically you're going to do the summation of them. So whatever operation that you've been given, maybe you've been told sum x and divide by a number like 4. So it will be 1 plus 5 plus 10 plus 15 divided by 4, which will be that 1 over 4. So that's the steps you take when you're dealing with the summation sign. We want to look at the measures of central tendency. And for the measures of central tendency, they have 3 common ones. We have the mean, mode, and median. And the first example we want to look at is ungrouped data. The example is the weight in kilograms of 10 students in a classroom is given there: 45, 68, 52, 49, 50, 58, 59, 55, 50, and 44. And therefore, we want to calculate the mean, the mode, and the median of the given data. The mean is also what we call the average value. And the mean is given by the summation of x divided by n. So what's the difference? N is the number of students. So n is equals to the 10 students. And x are their respective weights. So basically, if we want to get the mean, which can also be written as x bar, we pronounce this as x bar. We want to compute the x bar, and the x bar is given by 1 over 10 of the next set of values: 45 plus 68 plus 52 plus 49 plus 50 plus 58 plus 59 plus 55 plus 50 plus 44. We sum all those, and this is 530 divided by 10 after you do the summation of that. And that means the average or the mean weight is 53 kilograms. So the average weight is 53 kilograms. So the mode is the most frequent value. The most frequent value. And when we look through the data, we find that it's only one value that appears more than once. The others only appears once, and that is the 50 kgs. And since the 50 kilograms appears more than once, so we say the mode is 50 kilograms because mode is the most frequent value. And the last value that we want to compute for the ungrouped data is what we call the median, and the median is the mid-row value. And so how do we get the mid-row value? We organize our data in ascending manner or ascending form or ascending order. And so we have 44, 45, 49, 50. We also have another 50 there. So when you look at these values, because they are 10, then we realize that these two values are the ones at the center. Yes, those two values. So then I can say the median is given by 50 plus 52 divided by 2, which is 102 divided by 2, which is 51. And so you see that our median is 51 kilograms. So that is how we compute the median value for the ungrouped data, and also for the mode and for the mean. So the next step is to look at grouped data. For the grouped data, we are told that a group of 50 adults' cholesterol levels were measured and tabulated below. So those who had the cholesterol level of between 120 and 129, there were 4 adults. Those who had 130 to 139, there were 6. And those who had between 140 to 149, there were 17. Those who had 150 to 159, there were 13. And those who had 160 to 169 were 10. And therefore, if we calculate this, we see that we had a total of 50 adults. Now we are told to calculate the mean, the median, and the mode for the data, and that is what we want to do next. We have the same data, and what we want to do with the data this time is we want to fill in these values. What we want to get, the first thing is the CF, which is the cumulative frequency. The first value is 4. 4 plus 6 is 10. 10 plus 17 is 27. 27 plus 13 is 40. And 40 plus 10 is 50. What is the midpoint? The midpoint is 129 plus 120, then divide by 2, and that will give me 124.5. And then 130 plus 139 divided by 2 is 134.5. 140 plus 149 divided by 2 is 144.5. And then I have 150 plus 159 divided by 2 is 154.5. And then 160 plus 169 is 164.5. How do I get the f of x? It is f times x, and my midpoint automatically becomes my x value. So f times x, so it is 4 times 124.5 is 498. And then we have 6 times 134.5 is 807. And then we have 17 times 144.5 is 2456.5. And then we have 13 times 154.5 is 2008.5. And the last one is 10 times 164.5 is 1645. And when we sum all that, it will give me 7415. We are going, which is the x bar, which is given by, remember, for the ungrouped data we said summation of f, but now it is summation of fx. The fx we've just got divided by the summation of the frequencies. And we can know how many frequencies they are. We can see there are 50 people. So it is 7415 divided by 50. And that will give us 148.3. So the average cholesterol levels in this group of 50 adults is 148.3. And the median, there is a formula for grouped data when you're dealing with the median. It's given by L plus N over 2 minus the sum of the frequencies of the median divided by the frequency of the median times C. So what are these? The first thing is we need to be able to get the median class so that we understand this. Now, what is our median class? Is it the class at the center? No, not exactly. It is the person, the middle person, the median person, which class that person fall. Now, there are 50 values. If I was to divide 50 by 2, I will get 25. And I find that the 25th person is in the class of 140 to 149. It is very important to get that median class. Definitely, it's an even number. It should be between class 25 and 26. Because the median person is the median person is the person number 25 and 26. So it automatically means that our median class is 40 to 149. And so if that is the case, then what is L? L is the lower class boundary. What is the lowest class boundary for that class? Remember, the previous class is 130 to 139, and this is 140 to 149. So L will be between 139 and 140, so it will be 139.5. The class interval, I'll take the highest value, that is 149.5 minus 139.5, and I'll find that the class interval, which is C, is given by 10. N is the number of values, and in this case they are 50. So because there are 50 dots that we have. And FM is the frequency of the median class. So our median class is 140 to 149. So what is the frequency? The frequency is 17. What about summation of FM? This is you sum all the frequencies lower than the median class. And so which frequencies are lower than the median class? It is 4 and 6. And so that will give me 10. So with all those values, then I can get the median, which will be 139.5 plus 50 divided by 2 minus 10 over 17, then times 10 again. So those are the values that we have. And if we do the computations based on those values, we'll get 139.5 plus 50 divided by 2 is 25. 25 minus 10 is 15. So it is 15 over 17 times 10. And that will give us approximately 148.324. And that is the cholesterol level, the median cholesterol level that we have. The last is the mode, yes, which is given by the formula L plus delta 1 over delta 1 plus delta 2 times C. Now, the first thing is we need to get the model class. Now, when you look at the data, which one is the model class? The model class is the class with the highest frequency. And so our model class is 140 to 149. So our L automatically then, it's similar to the one we had. It is 139.5. And our C will also be equals to 10. So what we need to find out is what is delta 1 and what is delta 2. So now I take you back to the diagram so that we can calculate the delta 1 and the delta 2. Here we are. So this is the class we are interested in. So when you subtract these two, you get delta 1. And when you subtract these two, you get delta 2. So we are saying delta 1 will be 17 minus 6. And delta 2 will be 17 minus 13. So delta 1 is you take the frequency of the model class, you subtract with the frequency of the class that is lower, that is the class lower to it. So you say 17 minus 6 and you get 13. 17 minus 6 you get 11. And then 17 minus 13 you get 4. And therefore those are the two values that we are missing. So we have said for delta 1 it is 17 minus 6 is equals to 11, and this one will be 17 minus 13 is equals to 4. Measures of dispersion. We know that the measures of dispersion are standard deviation, variance, the age, the mean deviation, skewness, among others. And the first example we want to look at is ungrouped data. We have been given the weight of 10 students. And we want to use that to be able to do the computations that follows. So we have been given a number of activities to take care. One of them is the age. And the range is you take the highest x maximum minus the lowest value of x. And when you look at that data, the highest value is 68 and the lowest value is 44. And that gives us a range of 24. So the range is from the highest and the lowest. The second one is what would need to get is what we call the standard deviation or the mean deviation. So if I was to get the standard deviation, all I called SD, we need to get the mean, and we are going to calculate the mean so that we know how to calculate the standard deviation. The mean is given by x bar, which is the sum of x over n, and that means you sum all those values that you have there, and if you do that mathematics of summing all these values starting with 45 followed by 68 all the way to 44, and then you divide by 10, it will be giving us 530 divided by 10, and therefore we have a mean of 53. Now the question is, why do we need the mean when we are calculating the standard deviation? That is based on the formula for the standard deviation. The standard deviation is given by the summation of x minus x bar squared divided by n minus 1. Why are we dividing we use n minus 1 if n is less than or equals to 30. And since our n is 10 students, then this is the formula. So how does this work? We take each one of the values and then we square. We sum it. So the first value that we have is 45. So it's 45 minus 53 squared. You get the value. And then we have 68 minus 53 squared. And then the list goes on. We get the third one, which is 52 minus 53 squared. So our values will be positive because of the squaring of them. And then we have 50. Then we have 59 minus 53 squared, and then 55 minus 53 squared, and then finally we have the last two values, which will give me 50 minus 53 squared plus 44 minus 53 squared. And so 45 minus 53 is 8. This is 64 plus 13. Not 13, it's 15. 68 minus 53 is 15 squared is 225 plus 1 plus 16 plus 9 plus 25 plus 36 plus 4 plus 9 and plus 81. And if we do all that summation together, this will be equals to 470. The standard deviation is given by 470 divided by 10 minus 1, and then we get the square root, which is 470 divided by 9, the square root of that, and the standard deviation is 7.2265. So those are the deviations that we move away from the mean value. And then the variance is the standard deviation squared, so which will be 7.2265 squared, and that will give us the variance for that problem that we have. And finally we have what we call the mean deviation, which is given by summation of x minus x bar divided by n. So we are getting the absolute value of each one of them. So summation of x minus x bar will be equals to the absolute value of 45 minus 53 plus 68 minus 53 plus 52 minus 53 plus 49 minus 53 plus 50 minus 53 plus 58 minus 53 plus 59 minus 53 plus 55 minus 53 plus 50 minus 53, then plus 44 minus 53. So this is equals to 8. That is 45 minus 53 is negative 8. The absolute value of negative 8 is positive 8. 68 minus 53 is 15. Then 52 minus 53 is negative 1. The absolute value is positive. 49 minus 53 is 4. Negative. Absolute is positive. 50 minus 53 is negative 3. Absolute is positive. 58 minus 53 is 5. 59 minus 53 is 6. 55 minus 53 is 2. Negative 3. Then absolute is positive. This is negative 9. Absolute is positive. So those are the values we have. And this gives us 56, and therefore since we have 56, then the mean deviation should be equals 56 divided by 10, which is 5.6. So that is how we get the measures of dispersion for ungrouped data. For the second part, we want to look at grouped data. We have an example of 50 adults cholesterol levels that was measured and it was tabulated below. For those who had the cholesterol level between 120 and 129, there are 4 adults. 130 to 139, there are 6. 140 to 149, there are 17. 150 to 159, there are 13. And 160 to 169, there are 10. We are told to calculate the standard deviation, the variance, and the mean deviation for the data. So the first step is to itemize the formulas that we are going to use. For the mean deviation, it is given by the summation of frequency x minus x bar divided by n, and for the standard deviation, it is equals to summation of f x minus x bar squared divided by n, and then we get the square root of those values. So that is if we want to get the formulas, remember that you say that the mean deviation is given by summation of f x minus x bar divided by n. So the first thing is I need to get the midpoint, which is what we call x, and this is 124.5. How did I get 124.5? Is 120 plus 129 divided by 2. 130 plus 139 divided by 2 is 134.5. And then we have 144.5, 154.5, and then we have 164.5. The other thing I'll require is the x bar, which is the mean. So I need to get f times x. I'll multiply f times x. That is f times x is 498, 807, 2456.5. That is 17 times 1, 44.5. And then 13 times 154.5 is 2008.5. And then that is 1645. And then we have 7415, and therefore our mean is 7415 divided by 50, and that will give us 148.3. That is important for us to be able to get the mean deviation, which is f x minus x bar absolute value. And how do we do that? We take the x value 124.5, we minus 148.3, we make it absolute, means if it's positive, negative, we make it positive, and then we multiply by f, and if we do that, we'll get 95. So basically we are multiplying 4 times the absolute value of 124.5 minus 148.3, and that will give us 95.2. The next value, the frequency is 6. I get the absolute value of 134.5 minus 148.3, and the absolute value of that times 6, it will give me 82.3. The third one will be 17, then it will be 144.5 minus 148.3. I get the absolute value, and then I multiply by 17, and that will give me 64.6. Then the fourth one will be 154.5 minus 148.3. times 13 will be 80.6. And then finally, the third one is 10. 164.5 minus 148.3, and the value will be 162. So if I sum all this, it will be 485.2, and that will give me the value. Now with that value, then it's very easy for me to compute the mean deviation. The mean deviation will be given by 485.2. Then I will divide through by 50, and the answer will be 9.704, and that is the mean deviation. Now the last step is to calculate the standard deviation, and we have our classes here that you have been dealing with, and I want to rewrite them again so that we are able to follow through. 130 to 139, 140 to 149, 50 to 159, and then 160 to 169. We have the frequencies as 4, 6, 17, 13, and 10, and the midpoint we have is 124.5, 134.5, then we have 144.5, and 164.5. Remember, for this it is fx minus x bar squared, so this is 4. 124.5 minus 148.3 squared, and that will give me 2265.76. The second value, it is 6. 134.5 minus 148.3, you square, and that will give me 1142.64. The third one is 17. 144.5 minus 148.3, you square, and that will give me 245.48. And then the other one will be 13. 154.5 minus 148.3, you square, and that will give me 499.72. And the final one will be 10. 164.5 minus 148.3 squared. So it's 164.5 minus 148.3, 148.3, you square the answer, and then you multiply with 10, and that will give you 2624.4. If you sum this gives you 6778 as the final value of the summation. So that is the sum after you sum them up. And so what does that mean? It basically means then that the standard deviation is equals to 6778 divided by 50, and the square root of that will give me 11.643. What about the variance? The variance is equals to standard deviation squared, which is 11.643 squared, and that will give me 135.56. So that is how you compute the mean deviation, the standard deviation, and the variance of grouped data. Measures of position is our topic of interest, and we are told that they locate the relative position of a specific value in relation to the rest of the data. So these are what we want to look at, the measures of position. And we have three most popular measures of position: the percentiles, which is P1 to P99, and they divide the set of observations into 100 equal parts. We have the deciles, D1 to D9, and they divide observations into 10 equal parts. And then we also have the quartiles, Q1, Q2, Q3, and we can see in this illustration that they divide the data into 4 equal parts. So keeping that in mind, we want to go through them by looking at examples, both for grouped data and also ungrouped data. First thing we want to think about is which formula do we use when we are dealing with the percentiles, the deciles, and so forth. And we are thinking about example of ungrouped data. And if I just use the pk term, this will be n pk all over 100. And this will also apply even if it's the deciles I'm dealing with. The decade term will be n times dk all over 10. And that means also the quartile terms, the qk term is n times qk over 4. So that's what we want to keep in mind. And since we are dealing with grouped data, we can then look at the general formula, and we'll use the formula that helps us to find the median. The kth value, which is pk, will be given by L plus n k over 100 minus summation of the frequencies before the median class divide by the frequency of the median class. Formulation that we would want to use. So the following is the age of that students in a school. We have been given the age 8 to 12, 13 to 17, 18 to 22, 23 to 27, and 28 to 32 years. And we are given the number of students in each group of age. We are told to find the 20th percentile, the 6th decile, and the first quartile. So that's the process we want to take using that information there. And the first thing we want to keep in mind is we want to get the P20th term, which is given by n, which is the number of students, which is 30 times 20th percentile. And we see that it is the 6th observation. And the 6th observation is the 6th student. And the 6th student will be found in this group. 6th student will be in the age group of 13 to 17 years. So therefore we can get the 20th percentile, which is basically the lower class boundary of that, which is 0.5, plus 30 times 20 over 100 minus the sum of frequencies before that class, which is 3, times 17.5 minus 12.5, which is 5, divide by 5. And this will give us 12.5. This is 6 minus 3, which is 3, plus 3, which is 15.5 years. We can say that approximately 20% of the students are aged 15.5 years and below, meaning 80% of the students are aged 15.5 years and above. For the D6th term, first of all, we look for the position. They are 30 times 6 over 10, which is the 18th observation. Now, what do we know about the 18th student? Is in which age group? Now, looking at the cumulative frequencies, it should be between 18 and 22. Therefore, I can say that the D6 will be 17.5 plus 30 times 6 over 10 minus the sum of the frequencies before that class, which is 11, times 5, divide by the frequency of that class, which is 15. The sum of frequencies actually is not 11, but it is 8. 8 is given by 3 frequency of the first class plus the second class, which is 8. And therefore, this will give us 17.5 plus 18 minus 8 is 10 over 15 times 5. 1, 3, which is 15.5 plus 3.33, which is 20.8 20.83 years. The sixth decile, D1, D2, D3, D4, D5, D6 is 20. Then we have D7, D8, and D9 is up to there. So that's the set of information that we have, the D9 up to there, that gives us that set of information. And then the last one is the first quartile. That's now what we want to compute. And so the Q1, the Q1 term will be equals to n times 1 over 4, which is 7.5 term. Now, when you go to look at your analysis, the 7th to 8th student is in which class? He is aged between 13 and 17 years. Therefore, we can get the actual value, which is the L1, which is 12.5 plus 7.5 minus, because it's in the second class, minus 3, divide the frequency of that class, which is 5, then times 5, which is 12.5 plus 4.5, which is equals to 17 years. So we are given the salaries of 10 employees in an organization. Now we want to use this data to find, the first part is we want to find P80 or 80th percentile. The procedure is the same. So we get a P80 term, which is 10 times 80 over 100, which is the 8th term of your data. And it's very easy for this type of data. You just count 1, 2, 3, 4, 5, 6, 7, and 8. So we can say the P80 is equals to 80,000. So what does this mean? It basically means that approximately 80% of the employees earn 80,000 or less. That's basically what that set of information is telling us. So we want now to find D4. So the first thing is we get the D4 term, which is 10 times 4 over 10, which is the 4th term. And from the data, we know which term is the 4th. The 4th term is 50,000. So therefore, I can say D4 is equals to 50,000. For the ungrouped data, the procedure is more easier than for the grouped data.